important that you remember because I forgot always. Okay, so now you see, do you see GeoGebra? Do you see or no? Yes or no? Okay, look, I plot the point, 2,3,4, boom, I plot the point. And you can rotate and you can see the position for the point. How you plot that? Well, we have 3 segments. We have, for example, 1 segment here, 2. Guess this segment. This is Y value. No. Let's do it in this order. 2. Okay, 3. This is the left, yeah. 2 and 4. Bam! This is the position for the point and the plane and the space. 3D. It's clear, right? You are doing auxiliary segment line. From the first component get 2, and for the second component get 3, and we connect it on the XY plane, no? And after extending dependencies above or below, depending on the sign of the Z is positive 4, entonces up. Super easy. This is a straightforward, this is a kindergarten problem. Okay? So I will be able to plot any point using this idea and in the rectangular coordinate system. Okay. So we studied how you plot the point perfectly. Now I go to the 2 point. Okay, let me see. Okay. Let me come back to the whiteboard. Okay, whiteboard. Suppose now 2 point. Suppose the point I want to call P. By the way, let me say something. In GeoGebra, when you put capital letter P, GeoGebra understands it's a point. 2, -1,7. And we have another point, Q. So we study now 2 point, que es 1, -3,5. We can plot both points using the same idea we are doing in a few seconds. But the thing now is find the distance. Find the distance between PQ. Distance between the segment PQ. And the formula for the distance is the classical formula that we study in call it algebra, but we extending in 3 dimensions. So it's x2 minus x1 squared plus y2 minus y1 squared plus c2 minus c1 squared. And you find the square root of this. It's like an extension of the Pythagorean theorem. This is, for example, this is, I assume, this is my first point. This is x1, y1, z1. And this is the second point, x2, y2, c2. So you assume different notation, the answer doesn't change, because when you're subtracting, maybe change the sign, but when you square, it's the same. It actually is square root, big square root. You're subtracting the x component, que es, well, it's 2 minus 1 or 1 minus 2. It doesn't matter. It's 1 positive or 1 negative, but when you square become positive, it's 1 square. Plus subtracting the y. The y is from -3 to -1 is 2, no? Wait. -3, entonces es -3, minus, no, espérate, wait, this is positive. It's positive. Well, no, es negative, okay. Subtraction, es -3 minus 1 is 2, no? Es 2. The distance between -1 and -3 is 2. It doesn't matter si es, you remember, you're subtracting, it's +1, absolute value, es 2. And 2 squared 4. Plus the distance between 7 and 5 is also 2. O sea, es 7 minus 5 o 5 minus 7 es 2 squared 4. Entonces 8, 9 es 3. The distance between the point P and Q is 3. To see in the rectangular coordinate system, no? I'm using GeoGebra. Look at that. GeoGebra. Let me see. Here again, GeoGebra. Professor. Professor what? GeoGebra. Sorry. Carajo. Okay, there you go. Okay, we understand very well the point. Now we have 2 points. 2 points. The point are that point PQ. Bam. I plot that point. Wow. Entonces I need to find the distance. Two square 4. Okay. Okay, I plot the point. Pa. The segment que conecta both points is this. Boom. Okay, I create, look at that. I create here a segment. Look. You click here on this icon and you select segment. And the segment is in between 2 points. I select the point. You can do geometrically here. P, select the first point and the second point. And you here you see in the algebra part the segment, the length, the distance in between P and Q is 3. Mister, you understand your question about this is 2? Okay, this difference is 2. Square 4. This difference is 2. Square 4. This difference is 1. Square 1. It's not 16, no? It's addition. 8193. And your verification in Desmos, no? And your verification in this. Clear or confusing? Come on. But the question is before was -3. I have -3. What is the distance? What is the distance? Okay. I don't like the mathematics. I don't like the formula. I like the understand the concept. To post the line. Suppose the line. This is 0. This is -1. This is -2. And this is -3. My question is, what is the distance between -3 and -1? What is this? What is the distance? The distance is 2, right? Es -3 minus -1. Because the formula, suppose que I am fan to apply the formula, bueno, using the formula. The formula contains minus here. Okay, entonces es 2. ¿Es clear o no? Mister, clear o no? Yes or no? Good. Okay. Let me erase the board. We study now another object in 3D, que es a sphere. Okay, what is the equation for the sphere? You remember in algebra, pre-calculus. Circle. But in 3D it's a sphere. So what is the equation? Well, the equation is the same equation. Look, the distance equation is distance is equal square root x2 minus x1 square plus y2 minus y1 square plus c2 minus c1 square, right? This is the distance. But the sphere, by definition, is the surface such that we have one point at the center. Normally is h, k, l, because we have 3 dimensions, and equidistant to the one specific point. This is the radius normally we call r, and this point is the specific point on the sphere, x, y, z. We're using the same formula, The distance is a radio. So you want to eliminate the square root, you square both sides. R squared is equal x minus h squared plus y minus k squared plus z minus l squared. And the coordinate of the center is h comma k comma l. No? And this is the formula of the equation, sorry, of the sphere expressed in standard. Standard. You guys still... Oh, sorry, I forgot to switch it. Sorry. You need to help me. Because I concentrate in the mathematical part, so I forgot to switch into the... Okay, entonces, okay, let me see. Switching to bang. It's okay? Do you see the whiteboard now? Okay, the thing I tried to explain was sphere. A sphere is a surface. A sphere is like a basketball ball, right? But not solid. It's hollow. So inside, no. It's totally the surface, the outer surface of this. To get the equation for the sphere, we're using the distance formula, no? In 3D, we suppose that we have a center. We have one point on the sphere that represents the surface in 3D. Now I promise in a few seconds you see in GeoGebra the sketch or the graphic of the surface. But this is the formula. The formula is when you square both sides. This is similar. Yeah, you familiar in pre-calculus, in college algebra. We study for the circle. Circle is in 2D. Sphere is in 3D. Okay. This equation for the circle is x minus h squared plus y minus k squared equal r squared. So we have no c, we have no l. This is 3D. Okay. So I bring one interesting example. Suppose that we have example of the sphere. Example one of the sphere, right? Is suppose this x squared plus y squared plus c squared is equal ax minus 4y plus az minus 20. Entonces now the question say, well, determine the center and determine the radius of this sphere. So use identification of this sphere because we have the complete collection of the variable x, y, and z. See, at least one is missing, no es a sphere. Pero no, in this case, complete collection of the x, y, and z and square. Square. The identification super quickly that this is a sphere. Of course, this sphere is translated something, so we have some shift in the axis because we see here a linear term. But okay, we are doing similar to the pre-calculus. We complete the square. So I move everything to the left-hand side. X squared minus ax plus one box. In this box, I introduce a magic number that completes the square for the x part. Plus y squared plus 4y. I move 4y to the left-hand side. I change the sign. I put a box. Okay, help me the box to complete the square. Plus c squared minus az plus another box to complete the square. And the right-hand side, well, still stay minus 20 plus 3 boxes. 3 boxes. The first number in the first box is 16. Where I come from 16? You take 8 divided by 2 squared. This is a formula. The formula is b over 2 squared, complete square. I suppose you remember very well this. Now, the second is 4, because 4 divided by 2 is 2, 2 squared is 4, and the next one is 16 again. It's a coincidence, because it's 8. Doesn't matter, when it's a negative, positive, the answer is always positive. So we have 16, in order to keep the equilibrium for the equation, 16, 16, and 4. Okay? Well, so the factorization, that part is x minus 4 squared. The factorization, this trinomial is y plus 2, remember the sign. The sign is the first sign. This is minus, minus, this plus is plus, because the second sign is always positive. Plus z minus 4, no? Square, equal on the right hand side, 4 and 16 is 20, minus 20 cancel out everything, stays 16. So we discover this is the equation for the sphere, and this sphere, the center is located at the point 4, comma, negative 2, comma 4. Is center of this, and the radius is this is square root 16, que 4. Okay, and this is my entonces I can represent in GeoGebra if you want. If you want, you put in this way. Okay, you put in GeoGebra like that, or like that. It's the same sphere, right? It's equivalent. The only thing I did was the manipulation of the algebra. Let me try to find in GeoGebra. Okay, GeoGebra. Okay, open new. Okay, where is this? Oh, yeah. There you go. I found. Okay. Let me switch in the share screen to the GeoGebra. Boom, double boom. Okay, look at that. I have my rectangular coordinate system. You can change the position if you want. I put the equation for the original equation, or it doesn't matter, the equation for the bond. Okay, this is my sphere. You can change the color if you want. You can change the transparency. Here you go to the look. You click here. You go here to this. Do you see the GeoGebra, right? Yes or no? Guy me. Okay, good. Okay, you for example, you go to settings for the specific object. You select the object. You click in the 3 dots here, and you see the window specific for the setting, and you change the color if you want, and you change the opacity. Opacity means que es more solid or more transparent. This is the sphere. Okay. Now I suppose I have another sphere. Okay, let me come back to the whiteboard. Okay, we come back to the whiteboard, yes or no? Okay, continuation of this example. I want to complicate more your life. Always I complicate it. Okay, look. I suppose I have another sphere. Another sphere. And the equation of this sphere is x plus 2 squared plus y minus 3 squared plus c minus 2 squared equal 144. And again, I say, okay, this is sphere 1. Now this is sphere 2. Okay, and the sphere 2, the center is located at the point, negative 2, comma, positive 3, comma, positive 2. This is the center. And the radius of this, another sphere, radius is square root 144. Guess 12. So I suppose that this is, compare, this is 4, and this is 12. So this is the big sphere, and this is the small sphere. So I want to, using my common sense and my imagination, if, for example, the big sphere contain totally the small sphere. So what is the situation? The situation, you have big sphere, okay, the center is located in one specific point, is this point, and the radius is 12. And we have inside another small sphere. Okay, the center of this sphere is this. And the radius, I know, is 4. Okay, because I want to prove what is the objective, what is the goal of this part. Is we have another sphere, and this is another big sphere contain totally the small sphere, or no? Well, let me try to prove by contradiction. The radius of the big one is 12. Now I want to find the distance between the center. And also the distance, I compare the distance. Okay, the distance is, let me try. The distance between the center is square root distance between center 1, center 2 segment is equal, and you subtracting, look at the center, subtracting the x component is 4 minus 2 is 6. Do you see? It's 6. Okay, now is minus 2. The distance being minus, fi squared plus the distance between 4 and 2 is just 2 squared. Do you follow? This is 36, 25, and 4. This is 65. Okay, this is the irrational number. It's okay. This is the distance here. Let me use another color. Entonces, by contrast, is 4 plus a radius. Okay, a radius is a radius 4. Sorry, this distance is 4. But let me use in color. This distance, blue color, is 4. This distance, red color, is square root 65. Carajo, I change the color. Okay, look, erase everything. Using my common sense, no formula, common sense. Okay, square root 65 is the red segment. And 4 is the blue segment. And we compare that number. Square root 65 is, in decimal approximation, 8.06 plus 4. And this is 12. And 12 is greater than, okay, suppose que Suppose the big sphere contain completely 100% the small sphere. Entonces this is greater than, no? This question mark is greater than. But this is 12.06. This is a contradiction. This is completely false. That's mean que I suppose que the small sphere is a little bit outside this. A little bit. To confirmation que everything is okay. Oh no. Let's move on directly to GeoGebra. Okay, GeoGebra now. Wait a second. GeoGebra. Okay, good. Now, okay, I share screen one more time. Okay, look at that. GeoGebra. Okay, do you remember the red one? The red one is small sphere. Do you see GeoGebra now? Yes or no? Okay, we don't see GeoGebra. Okay, let me try again one more time. Okay, here you go. Now, yes, Annette Cruz, yes. Look, Annette, I plot now the second sphere. Bang, boom, it's a big one, right? So I had not clear. See the red one. We're doing here, provide the big sphere can contain, it is a goal. It's a goal. The goal is proof if the big sphere can put in gray color and the transparent or the opacity, I put it a little bit small to see inside the sphere, right? I discover that we have intersection. Bam, look at that, intersection, bam. Well, okay, this is another thing, okay? That means que something small, pero something of the small sphere is outside the big sphere. Okay? For a moment, that's the thing I want to illustrate. Only that part. Any question? Any question? Any question? No, sir. Okay. And it is very helpful. You help me, Annette, always. Okay, let's come back to the whiteboard. Let's come back to the whiteboard. Whiteboard now. Okay, good. Whiteboard now. Let me try now to start a new topic. Super important. The most important topic in your life. It's about vectors. Vectors. Maybe you see something about vector in the trigonometry class. I don't know, si you see or no. Or a physics class, okay? But this course, you know, it's good, but it's totally incomplete. We see now in detail, super detail. O sea, vectors. Vector is a quantity, it's a mathematical object que contain, so we can represent like a segment, but this segment have directions. There are many examples in the real life of the vector. So some quantity we cannot represent like a scalar. So for example, velocity, force, acceleration, etc. A lot of displacement. It's a typical physical quantity that you want to have the whole idea. You need to represent like a vector. So a vector contains two pieces of information: magnitude is the length of this segment. The length is equal to the length. Okay, indicates somehow for example, the stretchness of the, well, I don't know, force, 10 Newton. It's a vector. with the length is 10. Si es 20, well, entonces es a big length. And magnitude, and direction, sorry, direction. And direction, there are many ways to indicate direction. However, in my opinion, the best way to indicate direction is using univector. Univector. Okay, I want to explain in detail univector in a few seconds. Univector. So what is the notation? What is the notation? The vector in 3D. Well, we have two kinds of notation. We have two kinds. The first is using angular bracket, 3, 1, or 2, 1. In my paper, I have 2, 1. And this is equivalent, okay? When you see angular bracket, it's because it's a vector, okay? Now, to understand this idea is, look, we come back again to our famous rectangular coordinate system. This is Z. So we have univector in the direction of the axis, for example. Univector is a vector whose magnitude is 1. Univector magnitude is 1. Suppose we have a small vector, small, super small, in the same direction of the x. This vector, the component in this notation is 1, 0, 0. And this vector, everyone in the world know like a K. Like a I, sorry. I vector. And this indicate is, let me explain in detail after what the reason I put this hat. But no now. We have another univector case like that. And well, let me use green color for the Y. Green color for the Y. This vector is the vector 0, 1, 0, and it's the J vector, J. And K is blue in the Z direction. Is the vector 0, 0, 1, is K. It's a univector, so this vector I, J, and K is the trihedral, because it's three guys. Okay, they are orthonormal vector, normal vector. What mean that? Ortho, this word ortho in mathematics indicates 90 degrees. So the angle in between this vector is 90 degrees. And normal indicates the univector is the vector are univector. Univector means, I forgot to say in detail, univector means magnitude, the univector is equal 1. I promise in a few seconds I explain some example. But the most important moment now is you can write, if you want, this notation and in different notation. It's this 3i plus 2j plus 1k. Okay, this is the Hamilton notation. Some people prefer this notation. I prefer both, doesn't matter. Okay, using the univector I, J, and K. That's it. Okay. So now, let's come back to the how you compute the magnitude and how you compute the direction. The magnitude. What is the formula for the magnitude? Suppose we come back again to the same example. Vector A is a vector 3, 2, 1. We use exactly the same vector, no? By the way, guys, pay attention. In GeoGebra, how GeoGebra recognize that we are talking about vector or point? Well, in GeoGebra, you put capital letter. GeoGebra understands it's a point. However, if you put lowercase letter, GeoGebra understands it's a vector. But in the paper, no. In the paper, here, in the whiteboard, we're using for the point the regular parentheses, and however, in the vector we're using the triangular bracket. Okay. Entonces, what is the magnitude? The magnitude is like an absolute value. Some book prefer this notation. Double bar is a magnitude. But maybe in the book of the United States, American, using absolute value, but it's obvious that this is different, no? This is different. Okay, absolute value, a number. It's a number, no? It doesn't matter if it's positive or negative. But absolute value, a vector, is a magnitude. And the formula is square root each component separately. So 3 squared plus 2 squared plus 1 squared. Entonces 9, 13, 14, square root 14 is the magnitude of this vector. I ignore this notation. I prefer this notation, but I assume it's supposed default that when you're talking about this, it's a magnitude, no absolute value. As it's a scalar, and the scalar obviously it is absolute value. I suppose default that this is absolute value. I suppose default que es a magnitude. Okay? This is the position vector. Position vector is suppose 3, 2, 1. 1, 2, 3. And the x direction. 1, 2. And the y direction. And 1 in the z direction. Here. So you're connecting the origin 0, 0, 0 and the specific point, and this is the position vector. Position vector, when you're talking about position vector, is because you suppose default. Okay, remember the vector contain is a segment, but contain 2 points. This point is the arrow. This point is the start point. The start and end. And you suppose que star is 0, 0, 0 when you're talking about position vector. And the arrow is located in the position of the point 3, 2, 1. This is the idea for the position vector. However, in the real life, you can find another vector in between 2 points. Suppose que I have 2 points. Find the vector que represent the segment line. For example, you have a point A, que is the point 2, negative 3, 4. It's a point, no vector. And B is another point, que is negative 2, 1, 1. It's a point, 2 points. I want to find A, B vector. So it's a no position vector. Is now a vector in between 2 points. Entonces, I suppose, according to this notation, que B represents the arrow and A represents the starting point. Entonces, it's easy. You're subtracting because of the distance. Subtracting what? Subtracting x2 minus x1, comma, y2 minus y1, comma, c2 minus c1. In our case, the point 1 is this point, is x1, y1, c1, and this is x2, y2, c2. Basically, your subtracting is 2, positive 2, minus, no, es no, sorry, es B, minus x2, que es negative 2, minus 2, es negative 4, comma, is positive 1, minus 3 is 4 again, pero positive 4. And minus 3 is 1, positive 1, minus 4 is negative 3. Okay? Suppose que I want to find BA vector, que es en the opposite direction, ¿no? Entonces, you are doing, pero en opposite direction. Es obvio que es the same value, pero con opposite sign. 4, -4, and +3. Okay? That indicates also que is obviously opposite direction. Everyone follow me or are confusing? It's easy. This is elementary, kindergarten, right? What are the most important operations with the vector? Scaling. Scaling is multiplication any vector by the constant. Suppose we have a vector b and you multiply it by 2, and 2 represents scalar. So it's like that, 2b. Okay, 2 represents scalar. That means that the direction is multiplied by 2. The direction, no, sorry, the magnitude is multiplied by 2, but the direction stays the same. Suppose que you divide by 2, okay, entonces it's a short, a small vector, b divided by 2. The magnitude is affected by the scalar and the direction doesn't change. Well, it changes when you multiply by -1. This is completely, suppose que es minus b. Minus b is the same vector with the same magnitude but the opposite direction. It's the idea for this and this. This is scaling, super easy. Addition and subtraction. Let's do addition and subtraction. Addition and subtraction. Addition. Let me explain addition and subtraction. First of all, geometrically, and secondly, algebraically. For example, you have a vector A, and you have a vector B. I want to find A plus B. And you apply the parallelogram rule. You translate this vector B, this, and now this is the vector A plus B. Addition. Suppose algebraically. Suppose que is given vector A is 2, 3, 1. Vector B is -1, 4, 2. I suppose, no? 2, 0. Now, if you want to find the component of the A plus B vector, well, the only thing you should do is adding is 1, 7, and 1. 2 minus 1 is 1, 3 plus 4 is 7, 1 plus 1. This is the geometric representation, parallelogram rule, and actually it's the same thing algebraic. Okay, and subtraction. So subtraction is easy. Subtraction is, look, subtraction. Subtraction is, for example, you have the vector B again, same sketch, and the vector A. Similar to this. And you want to find subtraction, A minus B. Well, one possibility is minus B represent this vector. This is minus B in opposite direction. And you adding with the A using the parallelogram rule. Okay, and this is the vector A minus B. Another shortcut to do fast is you connect the arrow and the arrow. Look at that. You connect the arrow of the arrow. And this point to the vector that you consider the minus n and the subtrahend. No? Minus n is the arrow, and subtrahend is the tail, or the starting point of this. Okay, so you want to do algebraically, let's do it algebraically. Suppose que the vector A, well, es this example. Entonces, the vector A minus B is 2 minus 3, 4, 3 minus 4 is negative 1, and 1 minus 0 is 1. Subtraction. Super easy, eh? Any question, guys? Everyone follow me? Okay, now univector, univector. This is a moment to study in detail univector. Univector. Univector is a vector que the magnitude is 1, but what is the application? The application is indicate us the direction. Now suppose find the univector of the vector 2, negative 1, negative 2. Okay, the first thing you should do is find the magnitude of this magnitude. Magnitude is a square root. 2 square plus negative 1 square plus negative 2 square. This is, well, this is 4, 4, 8, 1, 9, 3. And you divide the vector, the original vector. Let me call C vector, why not? And the univector of C, I want to use in this notation. Univector of C is you divide every component by the magnitude. 2/3, comma, negative 1/3, comma, negative 2/3. And I guarantee you 100% que the magnitude of this vector is 1. So the magnitude of the univector C es obvio que the answer is 1 because it's univector. And the direction of the univector is in the same direction of the original vector que C. Okay, suppose this direction is in the same direction of the vector C, que es the original. Do you understand this or no? Yes or no? Guys, are you too quiet? Yes. Okay, you see before, no? You see before in physics or in trigonometry. Do you see before in one subject or no? What subject you see? Never you see? In physics, okay. Daniel say in physics. Pre-calculus, okay. Pre-calculus, perfect. Okay. Now let's move on to the most important topic today, que es dot product. Dot product. Let me erase the board. Okay, dot product. The dot product. Okay, dot product is, look, you have the vector A, dot product, you put dot, but you see a little bit bold dot B. What is the definition? What is the definition of dot product? Suppose que A vector, the components are A1, A2, A3. Dot product and the component of the B vector is B1, B2, B3. And the dot product by definition is the summation any component A, BA. Of course, I vary from 1 to 3 because we have 3 components. No? Actually, the formula is A1 times B1 by multiplication this and this plus A2, B2 plus, hey, noise, B3, A3, B3. This is definition. Pero notice que the answer for this is scalar. No vector anymore. So you multiply two vector. However, you get the scalar. This is special multiplication. This is dot product. I promise you we study. I don't know if today or no another kind of product. pero this is dot product, and the answer is scalar. Okay, and another way, this is definition. However, we have another formula for the A dot product B, que es magnitude of A, this is scalar, multiplication, magnitude B. Okay, this is dot product. This is the dot product, not to ball. This is the regular multiplication. Cosine theta. And who is theta? Well, theta is the angle between A and B. Suppose the vector A, suppose the vector B, and theta is the angle between this vector. Entonces, this is a fantastic property que we're using. Suppose que I want to find the angle in between two vectors. So the formula to find the angle in between two vectors, if you isolate here cosine theta is equal, at the top we have the dot product in between the vector, gets the number, divided by magnitude of each vector, separate multiplication. Of course, you find the cosine inverse both sides, so theta alone in degree of radian is cosine inverse of this formula. A dot product B of divided by magnitude A times magnitude B. Okay, this is the most important formula. Now, let's see example to understand more clear this. Suppose that we have application. Find the angles between two vectors in 3D, of course. So suppose that we have different point. Suppose that we have the point P, que es the point 1, 0, 0. Suppose that we have the point Q, que es the point 0, 1, 0. And suppose that we have the point R, que es the point 0, 0, 2. Okay, I plot the point in the rectangle coordinate system. Guys, I want to do by hand now, but I have the GeoGebra application, but I don't want to switch into GeoGebra. For example, I plot the first point, is this. This distance is 1. This is the point 1, 0, 0, que es P. I have another point que es 0, 1, 0, que es Q. This is the same distance, 1, 1. 0, 1, 0, que es Q. And we have R, que es 0, 0, 2, is on the Z-axis, C-axis, X-axis, Y-axis. 1, 2, here. This is R. The point 0, 0, 2. Entonces my goal is you have one vector, que es the vector PQ, que es that vector, look, PQ vector. Okay, try to find immediately now. And we have another vector, que es the vector PR vector. Okay, it's important, extremely important to understand what is the starting point and what is the arrow or ending point. PQ. So you remember the formula that we are using to determine the vector in between 2 points. For example, PQ is the vector, subtraction, Q is the arrow, entonces subtracting 0, minus 1 is -1, comma, 1 minus 0 is positive 1, comma, 0 minus 0 is 0. This is the vector, this is the expression, the vectorial component for the vector PQ Again, negative 1. Again, negative 1. Because it's 0 minus 1. Because I suppose que R is the arrow, the endpoint. 0 minus 0 is 0, comma, and 2 minus 0 is 2. So what is my goal? My goal is find the angle in between this vector. Theta, theta. That angle, look at that. Look at that. That angle. Okay, so we're using that formula. Let's do it. This formula is, I find the magnitude PQ. Magnitude PQ is square root negative 1 squared plus positive 1 squared plus 0 squared. Es obvio que es radical. Magnitude PR. Magnitude PR. Magnitude PR es obvio que es square root negative 1 squared again plus 0 squared plus 2 squared. It's radical 5. Okay, perfect. Now I find the dot product. Dot product. I find the dot product PQ, 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 dot product PR. Okay, guys, by the way, let me say something important. The dot product is commutative. So you are doing that order PQ first and PR second, or PR first and PQ second, and the answer is the same. Doesn't change the answer. PQ, so the dot product is completely commutative. You can't switch it. Another problem, no, but this, yes. Okay, entonces es multiplication. Multiplication, negative 1 and negative 1 is positive 1 plus 0 times 1, component by component is 0 plus 2 times 0 is 0. Wow, wow, everything is 0 except the first one is 1. Okay, entonces the angle in between is the formula. What formula is, at the top we have, okay, cosine, 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 cosine theta. Cosine theta is 1, que es the dot product, divided by magnitude is radical 2 times radical 5, radical 10. Now theta is equal cosine inverse of 1 over radical 10. Put in the calculator, is 71.5 degrees. Okay, this is the fantastic application of the dot product. But one more thing we need to see using the dot product. Everyone follow me? We'll be able to use it. Of course, not only calculator. No, Daniel, not only calculator. By the way, I need to know what kind of calculator you have. Of course, you can use a calculator and you can use it GeoGebra. And GeoGebra compute the magnitude and compute the dot product directly. I want to show you, but no, I don't know if I have time today. Let me finish this part. Of course, we can use everything, guys, in mathematics. Okay, I want to show you one more software throughout the course. Okay, another application, fantastic application for the dot product is determine the angle. Okay, however, when you perform the dot product, A dot product B, and give me a positive number, that means que the angle in between the vector are acute. Acute means less than 90 degrees, less than 90 degrees. This is the fantastic applications. You want to prove que it's acute multiplication, the answer is positive, it's acute. Si the answer is negative, it's obtuse. Greater than 90 degrees. It's obvious, no? Because cosine in the second quadrant is negative number, right? And extremely important. When the multiplication is 0, big 0, entonces es right angle. equal 90 degrees. And remember, the technical name when this situation happens is orthogonal vector. Orthogonal vector. Orthogonal is the technical word using the mathematician to call when the two vectors are 90 degrees. The angle in between is 90 degrees. Okay? Okay, well, I have only 5 minutes, coño. Okay, I bring one example. I don't know if we have time or not to conclude. Well, yeah. I have time because I skip the stupid arithmetic part. I skip the part that we can use in the calculator. Everyone, follow me so far. I want to see your answer. Marco, it's okay. Omar, Borja, Jocelyn Hernandez. 100% I follow with Professor. Daniela, don't hesitate to ask me any question. Okay, suppose now I want to complicate your life. Remember, I am very complicated, guys. And this subject is very complicated. Some people say, no. Calculus 2, no. Calculus 2 is nothing. Calculus 3 is nothing. It's the kindergarten guy. Calculus 3 is a big leaguer. Suppose we have 3 vectors. And we manipulate with these 3 vectors. The first vector is 1, 1, 3. The second vector B is x, negative 1, positive 1. And the third vector is W is 1, y, z. Okay. Entonces, some people is missing, so some component is missing in this vector because I declare like a variable. No? Okay. That's what the goal. The goal is find. You need to find x, y, and z value to be orthogonal vector, to be orthogonal vector. And after, when you find x, y, and z, you need to find also the new orthonormal M base. What mean that? Ortho is 90 degrees. Normal is univector. So I need to find x, y, and z in this problem to get u vector, b vector, and w vector be orthogonal. And also you find the unit vector of this. And this is formed the orthonormal base. Okay, it's 3 vector, unit vector, que es 90 degrees, similar to the IJK. Pero no es IJK because IJK is the classical orthonormal base. However, we have infinity possibility to find the orthonormal base. Okay, entonces I know que should be orthogonal. Orthogonal means que the unit vector u dot b is 0. Is -1 plus 3 should be 0. So multiplication x times 1 is x. -1 times +1 is -1. +1 times 3 is 3. Therefore, I compute directly that x is equal -2. Oh, okay, super. I found the first component I don't know, is x. Now, likewise, b dot product w, I select another couple, is, bueno, I suppose que I know that this guy is -2, ¿no? Entonces es -2, 1 times -2, minus y, plus z is equal to 0. Because my goal, remember, is orthogonal. Entonces the dot product always is 0. Entonces I have one equation, and the one equation is minus y plus z equal to. Okay, I need one equation, I need another equation, and solve c for it. So the last couple is u dot product w is obey 1. 1 times 1 is 1. 1, 1, 1. Plus y times 1 is y. Plus 3z equal 0. Entonces we have another equation, no? The equation is y plus 3z equal negative 1. So we have a system to see two equations, two unknown, apply maybe elimination, addition, this and this cancel out, ready for elimination. Entonces 4c equal negative 1. Negative 1, no positive 1. Therefore c is 1/4, 1/4. In order to find the y value, plug in either equation. I select the first one. Entonces negative y plus 1/4 equal to. Therefore, y is equal. I move with 2 minus. That's 2 minus, no? 2 minus, 1/4 minus 2, 1/4 minus 2, 1/4 minus 2. 1/4 minus 2 is negative 7/4. Okay, conclusion, super fantastic conclusion. Well, the vector u, I know at the beginning, is 1, 1, 3. But the vector b, I don't know. The vector b is negative 2, we discover here, comma, negative 1, positive 1. And the vector w is the vector 1 again, the first component, but the second component is y and z, and y is negative 7/4, and the z is 1/4. Okay, in this moment I have the collection, 3 normal vector, and if you want verification that they are orthogonal, you perform manually here the dot product, and you see the answer is always 0. Now what is the second part of the game? Well, the unit vector. Now what is the unit vector? What is the unit vector of u? What is the unit vector of b? And what is the unit vector of w? Well, to find the unit vector, the only thing you should do is find the magnitude one by one separately. Let's do it. Magnitude u is square root 1 square plus 1 square plus 3 square. It's square root 11 because it's 9 plus 1 plus 1, 11. Therefore, you divide everything by 11. Guys, there are different way to do that. Look, you select the style that you prefer. I understand everything. Or you divide each component by 11, 1 over radical 11, comma, 1 over radical 11, comma, 3 over radical 11. That's one possibility. Another possibility is you put 1 over radical 11 outside, you put 1, 1, 3. 1, 1, 3. This is acceptable. Acceptable for me, acceptable for my love, this answer. Or some people say, no, this is no good because you don't rationalize denominator. Well, it's okay, you multiply by, algebra, baby algebra. Magnitude b, magnitude b is similar, is radical 6. Verification here. Entonces now es minus 2 over radical 6, comma, negative 1 over radical 6, comma, 1 over radical 6, positive. And finally, magnitude w. You put this in together, is square root 66 over 4. And when you divide that, you get 4 over radical 66, comma, negative 7 over radical 66, comma, 1 over radical 66. And the final answer is the orthonormal base. And this is just orthogonal vector. orthogonal vector. Okay, too much for one day. Okay, any question? Please, do you see my face or no? Not yet? Do you see my face? Guys, I said the last time, I don't want que you change the background. No, the background is my face. Okay? Don't change this. I don't like this stone tree. Okay? Entonces, thank you so much. Okay, remember, today I will send the video, that video. Let me stop recording.